A very warm good evening to all our viewers. I welcome you all to the third session of DSC ML Talks event. I am Aman Sharma, the ML lead at DSC VIT Bhopal, and we have here among us the entire DSC ML team, Ayush Mishra, Indrashish Paul, and Yash Sinha. As you all know, the DSC ML Talks is a month-long event where we'll be organizing hands-on workshops aimed at getting you started with the field of machine learning. This session is a hands-on workshop for exploratory data analysis using Matplotlib and Seaborne. Now, when it comes to working with data, EDA plays a very important role. It helps to extract some useful insights from the data that might not be very clearly visible if we are just simply observing the raw data set. In today's session, you will be learning about some of the important data analysis techniques. So without any further ado, let's kick off our event. We'll be beginning with Indrashish giving you a short introduction on Matplotlib. Over to you, Indrashish.
That was a great introduction, Aman. So, without any further ado, let's get started with the first topic of the day, Matplotlib. So, to give an introduction, Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python, be it any figure, graph, charts, literally anything that can be implemented from data and we can gain insight from. It is one of the most widely used Python libraries for data visualization. And to be honest, it's quite heavily used throughout the Python community. It's open source, easy to use, and can provide very high quality figures. I've also included the link to the documentation. You can go and hover over it and go and check it out. So the first thing is why we use Matplotlib. So there are various reasons for using Matplotlib, and one of the primary reasons is it produces production quality or publication quality figures in a variety of hard copy formats with just a few lines of code. For example, if you're writing a publication, a research paper, and you want to include some quality and very good-looking figures in your paper, so Matplotlib will be the first choice for you to go. It is also very flexible in producing figures, and it provides a wide range of customization options to you. You can change your figure options. You can change the color options. You can do various other things with your figures and tinker with it, and it will give you a final result according to what you want. It's also built on top of NumPy arrays and designed to work with most of the SciPy stack, so giving you an edge on working with NumPy, since we have already introduced NumPy in our previous session, and we have also seen how much efficient NumPy can be, and Matplotlib is just built on top of NumPy. And Matplotlib can be used in Python scripts, Python and IPython shell, web application servers like Jupyter or Google Colab, and various other graphical user interfaces cross-platform because its code is written in C, Objective-C, and JavaScript, which gives it platform independence. Now, the most important thing when it comes to using Matplotlib is the installation, and just like the previous sessions, we'll be installing it through CMD or terminal. So Matplotlib is a part of Anaconda distribution, and it can be installed through either through Anaconda or Miniconda. And the command for that is conda install Matplotlib. Its same official version can be installed from Matplotlib from PyPy itself using pip, and the command for that is pip install Matplotlib. That's about it for the introduction of the Matplotlib, and let's get started with some hands-on experience with Matplotlib. Aish will walk you through the the total of the code in Google Colab. Over to Ayush.
All right, everyone. Good evening, and welcome back to another session on exploratory data analysis. And thanks, Indrashish, for giving that awesome introduction on Matplotlib. And right now, I'll just walk you through the entire code and how you can start off writing your own code in Matplotlib. So, as usual, we'll be using Google Colab, just like last time. I'm pretty sure you are familiar with how to import the notebooks and stuff. So all of this will be available on GitHub. So make sure you go there and get these notebooks for yourself. pay good attention to what is happening right now, because following this hands-on tutorial, you'll be having a quiz that you will need to be answered, that you will have to answer. So yeah, let's quickly begin with the tutorial. So the very first thing is, how do we import Matplotlib in our code base? So we last time we used NumPy and pandas, and we will be making use of it again. And we use this code import matplotlib.pyplot as plt to import Matplotlib in our code base. And once we run the cell, we hit shift enter to run our cell, and we have it ready in our book. Now let's get on to some plotting some graphs. So we'll be using NumPy over here, and the very first plot is the very first command is plt.plot. So what is happening over here is that right now we don't have any data to plot, so we'll be creating our data using the nb.linspace 0,5. So as you know, it creates an evenly distributed it creates basically even space number between a fixed interval. So we are creating that data using this, and once I run this, you will be able to see the plot. So what plt.plot is doing is that it's creating this line for us that you see over here. So these are the numbers, and these are the squares of their numbers, as you can see, because x is zero number evenly distributed between 0 to 5, and y is the squares of each number. So this is the line that we have over here. These are the numbers, and these are the squares. So plt.plot is plotting a relationship between the numbers and their squares, and plt.show is used to in one sense we can say to print the plot that we have, or to see what it actually looks like. Once you're done with this, we can move on and talk about what are axes and what enhancements can we do in this plot. So in the above plot, as you can see, you are not sure what exactly this axis represents or this axis represents if I had not told you. So what we can do is we can give these axis labels, and overall we can give the whole graph a title. So what we are doing over here is that we are plotting the same graph, but when I run it, you will be able to see the axis label. So we are using plt.x label and passing in the string that we want in order to or whatever will be displayed over here. So we are we are passing numbers x, which is our x-axis, and similarly for y-axis we are passing the squares or number y, which will be the title or the string that will be printed over here. And overall we are using plt.title to give a title to our graph, which is number versus the square. And once again we are using plt.show in order to print or see the whole plot. Once we are done with that, we are moving on to figures and axis. Now these are two terms that you might get confused with, so I'll try to explain it in the most friendly and understandable way. So what basically figures is, it can be thought of as a container in which you can store multiple plots. So think of it as a placeholder where you can keep multiple plots at one time. And when it comes to axis, we'll just see it is basically the area in which the plot appears. All right. So these are the commands that we'll be using. You don't need to worry, because all of this notebook will be available to you on GitHub, so you can always go there and get to know these commands very well. And this is a collab notebook, so obviously you can run it on your local system as well. So when I run this cell, you'll be able to see this graph. So I'll explain what's happening over here. Now we are creating a figure. Fig or fig is equal to plt.figure. This is how you create your own figure, as I said, the container in which your plots will be. Axis is equal to fig.add axis. So you're adding access to the figure that you created, or the container in which the container that you created basically. And it takes some parameters over here, which I'll be explaining in just a while. We have x over here, and the similar thing that we did. So we have an additional variable over here, z, which cubes x or raises it to the power 3. And so what is happening over here is that we have passed 0, 0, 2, 1 and 0, 1, 2, 1. So what does this 0, 0 indicate? So 0, the very first parameter that we are passing is basically the horizontal coordinate of the left corner. So when we are plotting this, if you see closely, think of this whole axis as the y-axis and this as the x-axis. All right. So when I say 0, 0, that will be considered to be this point right over here. And similarly, when I say 0, 1, it will be considered to be the point over here. All right. Similarly, when we are talking about 2 and 1, 2 is basically our width, and 2 is our width, and 1 is our height over here. So as you can see, it is the whole graph is wide, which is obviously greater than the height of the whole plot. So both of these are of height 1, and width is 2 for both of them. So as you can see, you can create multiple plots in one figure using this method. Again, we can set X label and Y label for both the plots, as well as the titles for both the plots, like we did using the set X label, set Y label, set title command, and plt.show to print the whole plot. Moving on, we created multiple axes over here. So we'll also running through another example with some decimal values over here that we'll be passing. So as you can see, we have a large plot, and inside that we are including this small plot. So this is another example of using multiple axes. Now I recommend you play around with these values so you better understand what's actually happening over here. I just explained you what each of the parameters are and how you can change them, how you changing them affects the whole plot in total. So play around with these values and figure out for yourself what changes can you bring in your graph using this changing these parameters. Moving on, we'll be taking a look at subplots. Now, subplots is basically creating multiple plots in basically in one cell, or I would say on a one canvas. So this is basically how a subplot would look like. I'll just run this command for you. So as you can see, fig is equal to plt.figure, which creates a figure that we saw above. And we'll be using plt.subplots, which will be taking two parameters, and we'll be creating subplots using it. So basically what we are doing is we are able to create multiple plots in just one figure. For example, if we have multiple columns that we wish to visualize, or if we have a column which we need to visualize in multiple ways, so we can use this command in order to do so. So what we are doing is when we are giving the command plt.subplots n rows equal to 1 and n columns equal to 2, what we mean is that this whole thing is one row, and we are providing two columns over here. So this in entirety is what subplots does. It helps you to create multiple plots in just one canvas. Now, many times, this is just a note that you can remember. So many a times your axes might overlap, and in order to separate both of these and make them look separated, you can use the command plt.tightlayout, which will basically manage both of your subplots and would minimize the overlapping or eradicate the overlapping. So now that you have created a figure, you can also change the size of the figure that you have created. So we'll be using the command fig size in order to change the size of a figure. So we are passing the width and the height over here. So this is basically the whole command. X is equal to linspace. These two are the same commands that we are using for plotting our graph. We are creating a figure, and we are giving fig size is equal to 5,2. So over here, the width is 5 and the height is 2. So this one is the width and this is the height that we are using. And when I run this, you'll be able to see that the width is greater than the height. So you already know. And yeah, basically we are creating an axis over here using the add axis that we just saw. And we are basically plotting all of it. Next up, we have legends that we can use. So in this case, we know what this was just a single line that we had, and we know what relationship it depicts. But in many cases, it might have you have multiple lines in your plot. So you can make use of legends in order to know what line represents what. So here we have linspace x equal to linspace 0,5. We are creating a figure over here, and then we are adding an axis to it. Now we are just plotting the curves that we want, which is the x squared and x cubed. And as you can see, this is what we call a legend, which tells us that the blue line is for the squared values and yellow line is for the cubed values. So this is how it looks in total. You can also go ahead and add your own axis labels that we just saw using the set underscore x label and set underscore y label and set underscore title commands. We can also play around with changing the colors and the style of the line that we have. So once I go here and run this command, so once we have given the command, we have the data points that we need to plot. What we are doing is we are creating an axis over here, and while we are plotting them, we are specifying some colors and also the line width So when you pass color equal to red, that means the line that you're creating will be of color red. And when you're giving line width equal to 5, it will just change the width of the line to 5. Similarly, you can also give a line style. So I have created the second line, which in a dashed form. You can change it and give some other symbol as well, or asterisk or some other symbol that you like. And I've changed the color to purple over here. So using this command, you can make your own specialized line that you want to depict two different lines. If you have multiple lines, this command can help you a lot in determining which line depicts what, and distinguishing between two lines. Now let's talk about markers. So what markers are is basically it gives you a better picture of where your data points are on the curve that you have plotted just. So when I run this command, you will be able to see this line, and these are the data points that we have over here. The command are same, just like we started off with. We are giving the fig size over here 10,5. So width is 10 and height is 5. We are adding our axis. We are plotting the curve. The color of the line is purple. The width is 5. And we are using the command marker equal to O over here, which determines this marker that we have for each data point. We are giving the size of the marker equal to 10, which determines the size. So you can play around with the how big you wish to see the marker on your plot. We are giving the marker face color, which is yellow. So this is the color that will be appearing to you. So you can play around with this and change the type of color that you wish to see. We are giving the marker width 2, which is 3, and marker edge color, which is black. So as you can see, there is an edge over here. So we are giving that a color black. And as usual, we are setting the X labels, Y labels, and the title for our curve. And once we plot this, this is the end result that we have. This will help you a lot in determining where your data points are on the curve that you just plotted. So it might help you a lot. Now, saving your plot. When it comes to saving your plot, fig.savefig is your go-to command to save your plot. And you just need to give the name of the plot that you wish to store, and the extension to which you want to use to store the plot. Now, one last thing before we finish up Matplotlib is that we'll be using plt.imshow and passing the file path, which will help in plotting an image. If you have an image that you wish to plot, you can use the plt.imshow and pass the file path, and it will plot the image out for you, just like it plotted out these graphs. So with this, we come to an end to the Matplotlib notebook. Let me just recap everything that we did. So very firstly, we studied how to import Matplotlib into our system, into our notebooks, and use it. This is the command that we use to import Matplotlib. This is how. Then we started off by using plt.plot command and to plot our very first graph. But the graph did not have any axis labels for us to know what exactly those axes represented. So we used x-axis and the y-axis. We gave them the labels using these commands. Then we went on to talk about figures and axis and how we can use multiple axes in order to plot multiple graphs in just one canvas. And then we also went ahead and talked about subplots. That is how we can include multiple plots without how we can include multiple plots in our graph in the same figure or canvas. We talked about how we can change the figure size depending upon how we wish to see the whole graph. We learned about legends, how we use them. We learned about the styling of these lines, how we can add markers to our lines in order to better visualize the data points. We learned about saving the plots, and then we also learned how we can plot an image. So with this, we come to an end to the Matplotlib notebook and hands-on tutorial. This notebook will be available on GitHub for you to access. Now we go on to a quiz, and Matplotlib is just, you can say, a basic tool that will help you to plot graphs. But later on in this session, we'll be taking a look at Seaborne, which just takes Matplotlib to a whole another level. So let's go on to the quiz now. I'll ask Aman to take it from here.
Alright guys, so on to the fun part now. We'll be organizing a quick quiz on Matplotlib, and you have to answer fast because the first one to answer will be the lucky winner. That is, the first one with the highest score will be the lucky winner. And I'll be dropping the link for the quiz in the chat now. So you better be ready for this one. And the timer will be starting now. So Go ahead and attend the quiz. Best of luck to everyone. Okay, guys, time for the quiz is up now, and we won't be accepting any more answers from you guys. And now we'll be moving on to the second half of the session where you will see how to use Seaborne for data analysis. So over to you, Indrashishaka.
That was a great session on the use of Matplotlib by Ayush. And as he indicated, we'll now move on to the plotting part with Seaborne. I'll just give a quick introduction to what Seaborne is and how we use it and why is it actually better than Matplotlib. So Seaborne is another Python data visualization library, and it's based on Matplotlib itself. It provides a very high level interface for drawing attractive and informative statistical graphs, just as Matplotlib did, but in a much better way. It's open source, easy to use, and it provides high quality and cool themed features. I've also included the link here again for the documentation. You can go and check it out. Now, why Seaborne? First of all, Seaborne produces production quality figures just as Matplotlib did, but with even fewer lines of code. But not just that, it can actually along with more amount of flexibility and customization options. It provides really beautiful and colorful themes to decorate your Matplotlib figures and graphics. It's also built on top of Matplotlib that I told previously, and it's integrated closely with NumPy arrays as well as pandas data structure. So you can use both NumPy arrays and pandas data frames or series to plot any kinds of figures and attractive and insightful figures using Seaborne. Moreover, Seaborne provides a dataset oriented approach towards plotting, which lets us focus more on the plotting side, on the plotting details, rather than how to draw or how to plot it. So we'll explore more about Seaborne and how cool and how beautiful it can be in the following code walkthrough session. But before that, we need to install it. But we already know the installation process. Seaborne is again a part of the Anaconda distribution and can be installed using the command conda install Seaborne. And the official release again of Seaborne can be installed via pip from PyPy using pip install Seaborne. So without further ado, I'll let Yash start with a hands-on experience on Seaborne using Google Colab. Over to you, Yash.
Thanks, Indrashish. So now we'll be starting with the Seaborne tutorial. So first of all, for importing Seaborne, we will just write import Seaborne as SNS. We will use SNS because it's easy to write. So first we'll have to load a dataset. So we are using a dataset which is already included in the SNS, which is called tips. So we will be seeing the first 5 rows of the tips dataset. First one is the total bill. So here we are dealing with the customers of a restaurant, maybe. So the total bill. Then the second column is tip given by the customer. Third column is the sex of the customer. Fourth column is whether that customer is a smoker or not. Then another column is day, on what day the customer came to eat. And the another column is time. So only 2 times are mentioned here, dinner and lunch. And the last column is size, which tells us how many customers came as a group. So first of all, we will be making disk plots. So basically disk plots are like a histogram, and we add to them a parameter called KDE, that is kernel density estimation, which is a way to estimate probability density function of a continuous random variable. People will be studying it in the second year, so you can leave it for now. So here we are plotting a disk plot of the total bill column of the dataset. So that simply is sns.diskplot tips, and this is the column, and that is total bill. So here we can see that most of the times the total bill is around 14 to 20, 10, about 20 to $20, and here is the probability density function. If you do not want this KD line or probability density function line, you can just set KD equal to false, and you'll just have a histogram which is the same. So the inference which we can see from this is that the most common total bill is about $10 to $18. Next plot is joint plot. So it is a combination of scatter plot and a histogram. This can help us compare the two variables. So here we are making a joint plot between total bill on the x-axis and tip on the y-axis. And the data which we'll be using will be the tips. So here we can see that most of the total bills are around $10 to $18, and most of the tips are around $2 to $4, or maybe $2 to $3. Now we will use another parameter which in the joint plot, that is kind. So if we use kind is equal to hex, all our scatter plots will be in a hexagonal manner. We can also use another parameter for kind, that is reg. So reg basically draws a regression line among them. So this regression line is the line which has the least difference between this plotted point and the line. So what inference we can draw from this is that customers don't tip a lot of money. Most of the tips are around $2 to $4, which you can easily see here. So the next plot is bar plot. So it is a categorical plot. It shows relation between categorical data and at least one numerical column. So here we will be drawing a bar plot between sex and the total bill, and the data will be on tips. So here you can see the male mostly have a total bill of about $20 or $22, whereas the females have a total bill of around $17 or $16. Then you can also rotate these in order to have a different look, but it's the same. It's just that we have changed the axis. So one simple inference can be drawn that males spend more than female customers. So another plot is count plot. So it shows the count of observations or the count of number of rows in each category. So we will be doing sns.count plot, x is equal to sex and data is equal to tips. So here we can see that most of the customers are male, that is about 154 or 155, and about 80 female customers are there. So basically we can have inference that more male gives tips, but that also depends on the number of customers. So another graphical representation is heat map. So it is used to find correlation between different columns. So the simple command is sns.heatmap tips.corr. COR represents the correlation and anode is equal to true. So anode basically means that this particular value is written here for each of the rows and columns. So here we can see the total bill and tip have a correlation factor of 0.68. So the more the correlation factor, the more amount of same values they have. And the correlation factor between the size and the total bill is 0.6, and the correlation factor between tip and size is 0.49. So what we can draw conclusion from this is that tip and total bill are related. And if we maybe take a multiple regression model, we might only use one column among total bill or tip. So the next plot is box plot. These are very basic plots used to visualize distributions, and it is useful in comparing data between two groups or many groups. So here we are making box plot between the day and the total bill, and the data is tips. So what the lower line represents the lower value of the interquartile range, which is about $8 on Thursday. Then this particular box represents the 0.25% or 25 percentile of the total bills, and that ranges from about $12 to $16. Then this middle line represents the median value, which is about $16, and this upper box represents the above 25 percentile value of the total bills, which ranges from 16 to 25. This value represents the maximum value of interquartile range, which is found by a formula that is 1.25 into interquartile range. That means 1.25 into 20 minus 12, that is 8. And these represent the extra value of the values which did not lie inside the interquartile range, and they're also called as outliers. So the total bills above $30 are considered outliers here. Then the inference which we can draw from here is that people spend the maximum amount of money on Sunday, since you can easily see the median amount of money spent on a Sunday is $20, and the maximum amount of money spent is about $40. And we can also plot this by just rotating it, and it's the same thing. So the next plot is line plot. It is used to show the relation between two variables x and y for various subsets. It depicts the relationship between continuous as well as categorical values in continuous data point frame. So we will be making a line plot between total bill and tip, and u will be sex and data will be tips. So what we can see here is that the total bill ranges a bit differently for the male and female customers. Maybe the males spend a bit more money than the females, since we can see here that there are more number of blue lines than green lines. The next plot is scatter plot. So it compares two variables by plotting the data points. We can also compare other features by using the U, and it really helps in seeing how your data is distributed. So we will be making a scatter plot between the total bill and the tip, and data is equal to tips and U is equal to time. So you can see that most of the plottings here are for dinner, and their total bill lies around $10 to $20, and a few other outliers have total bill of more than $25. So we have come to an end to our Seaborne tutorial, and now I will hand over to Aman.
Alright guys, so now we'll be doing a second quiz for the session. So this is the final quiz and I want all of you to participate in this quiz. Remember, the first ones to get the maximum score will be getting cool DSC specs. So I'll be dropping the link now. Again, the time will be only 2 minutes, so be quick. The link is available now and the timer is starting, so you can go ahead and attempt the quiz. The time's almost up, so please be quick. Okay, guys, so the time's up for the quiz now, and we won't be accepting any more responses from you guys. The winners for both the quizzes will be announced by tomorrow at the latest, and I've dropped the link for the OD form in the chat once again, so make sure that you fill that form before midnight. And with this, we come to an end of our third session for DSC ML Talks, and we really hope that you guys got to learn something from this session. In case you guys have any doubts regarding anything, you can just feel free to drop your doubts in our DSC ML server. And the link is again dropped in the chat, so it's right now flashing on the screen as well. If you have any doubts regarding anything, feel free to ask them in the DSC server. So I guess we can end the session now. All right, guys, have a great day. Goodbye, and see you in the next session.
Thank
All
you.
right, guys. See you.
Bye bye, guys. See you in the next session.